We're going to be going over Boolean expressions and object comparison. We're going to start by looking at two operators that help us compare variables. So we're going to look at and, ampersand, ampersand, and or, which is bar, bar. If we start looking at and, we're going to have to say there's going to be some expression on the left side, and then there's going to be another expression on the right side. And if both of them are true, then the whole expression will evaluate to true. Usually you would use this with an if statement, so that if the expression that is connected by and evaluates true, then you would end up doing something. Otherwise, you don't do anything. So let's take a couple of expressions. And in this case, we're just going to have two variables. One variable is going to be called first expression, and the other one is going to be called second expression. First expression is going to evaluate to true, and then second expression is going to be false. And requires both expressions, the one on the left and the one on the right, to both be true. Only one being true evaluates to false. Both of them being false evaluates to false. Both of them being true evaluates to true. So in this case, only one of them is true. So the if statement will not execute, and instead the else statement will execute. So that what this would do is that it would print out no way. An expression doesn't just have to be true or false. It can be something that has been compared to with an operator. In the case of the first expression, we have 5 minus 6, which would evaluate to true. And then we have 10 is greater than 9, which would evaluate to true as well. So in this case, both of them are true. And you can think of it as the same as saying this. You can have two expressions on either side that evaluate to either true or false. Anything that ends up being true or false at some point, whether it's just the words true or false, or some expression that evaluates to true or false, can be put on either side of the and operator and can be used with an if statement to say, do this line, otherwise do this other line. On the other hand, if we have or, then it means that only one of them has to be true. What if both of them are true? That's okay because one of them is still true. So it has to be at least one of them to be true for the whole expression to be true. So in this case, 5 is less than 6, sorry. So 5 is less than 6 evaluates to true. 10 is greater than 9 also evaluates to true, so the whole expression would evaluate to true. So we would be saying if this expression evaluates to true, print out all good, otherwise print out no way. In this case, we would print out all good because our comparison between the left side and the right side ends up being true. Now what if we had this? Only one side is true, the other side is false. Well, again, the or operator only requires at least one of them to be true for the whole thing to be true. So 5 is less than 6 is true. Doesn't matter what the rest is because we already found at least one true. And then we would go ahead and execute for the if statement what we have under brackets. Let's take another example. If we had 58 is less than 6, which is false, or 99 is greater than 100, which is also false. So because both of them are false, then our if statement says if this is true, then print out all good. Otherwise, if it's not true, print out no way. So our statement is not true. Our statement is false. So then we would print out no way. Let's take this example, which we've looked at before in class. So we look at the first comparison, which is x is greater than 15. Say 12 is greater than 15, that is false. So this would evaluate to false. And then we'd say, is x less than 18? Is 12 less than 18? Yes, that is true. Is x greater than 10? It's true, 12 is greater than 10. And then is y less than 20? Or y is not less than 20, y is exactly 20. So then that would be false. Now we still have a few things that we have to look at. So the and operator has things to the left and right. And then we have another and an operator, or sorry, or operator who has things to the left and right. And then we have another or operator who has things to the left and right. So we're going to do our leftmost parentheses and operator expression first. So false and true. Again, both of them have to be true. If both of them are not true, the whole thing under parentheses would end up being false. So on this side, we're going to end up with false. Now on the right side, we have true or false. So one of them has to be true at least. This whole thing would evaluate to true. And then we have or. So at least one of them has to be true for the whole thing to be true. And we do have at least one. So then this whole thing would be true. So it says if this whole thing evaluated to true, it did, go ahead and print out all good. So all good would be printed out. Now we're going to skip over a couple and we're going to look at one other example that uses some variables. Now we have this example that says x is greater than 15, x is not greater than 15, so that evaluates to false. Then we have val, which happens to be a Boolean variable that we've already defined as false, so that's going to be false. Then we have is good, which happens to be true because that's what we've given it as the variable at the top, and our value will be true in that case. And then we have val again, which is false because we've already defined that and we have false. And now we can go ahead and evaluate this whole thing. False and then false, well, both of them are not true, so this whole thing ends up being false. True or false, so there's at least one true, so the whole thing becomes true. And then here is, again, false or true. Is there at least one true? There is, so the whole thing becomes true. It says if this whole expression evaluated to true, it did, print out all good, will print out all good. Let's move on to string methods. Now we're going to look at 5 different string methods. Dot equals, index of, substring, 2 lowercase and 2 uppercase. We're going to start with dot equals. Before we get into dot equals, we're going to look at equals equals. Like, why could you not use equals equals with strings? Well, let's look at how computers store memory. So computers have different slots, and in each slot, they will put in some value. And let's call each one of those slots spot in memory. And to be able to find that spot in memory, we're going to use an address. So say if you go to address 97 and take out the contents, you're going to find Jamie. If you go to address 98, you're going to find James, and you go to address 99, you're going to find 10, or the number 10. And why do we have a 0x at the front? Well, usually for computers to know that you're talking about a address, you put 0x as a prefix, and then give it the number, and then it'll be able to say, okay, I know I'm looking for an address. So in this case, if we were to do something like this, name1 equals equals name2, what we're saying is, do these two have the exact same address? So name1, which is Jamie, has the address 97. Name2, which is James, has the address 98. They do not have the same address, so they are not equal in this case. And that's all we're really saying with equals equals. But what we actually want is to use something like dot equals so that we say, do they have the same characters? Does Jamie and James have the exact same characters within that string? And how does equals do that? Well, it takes both strings and then it looks at the first character and says, is that the same string? Yes. And if it is, then it moves on to the next string. If it's not, then it says, nope, they're not equal. I already found a string that's not the same. I'm done. But in this case, the second strings are the same and the third strings are the same. And then finally it gets to the fourth strings and it says, oh, okay, one is I and the other one is E. So in this case, dot equals will return false. I'll say, nope, these are not the same string. They don't have the same characters. And it doesn't care about the addresses. That's not really what you're looking for. You're trying to find the values. So dot equals will actually help you find the values as opposed to the addresses. So be careful in how you use equals equals with strings. Now, when we're looking at, say, an example like this one, S1 is high, S2 is by, S3 is high. In this case, S1 would have some address, S2 would have some other address, S3 would have some other address. And then in the last line, we say S2 equals S1. So what we're going to say is S2 will be the same address and the same contents as S1. So both of these variables are just going to say, look at this spot in memory. So S1 and S2 will look at the same exact spot in memory, and that spot will hold the value high. So if we did something like, say, is S1 equals S2, that should return true because they have the same address. But if we did something like S3 equals S1, then that won't return true because they do not have the same address. If we did S3 dot equals S1, they both have the word high and the same character, so that would return true. Let's look at index ofs. Now with index of, we're trying to find a string within another string. So in this case, we have the string George, and we're trying to find the substring or a smaller string OR inside of the bigger string George. If we find that string, it's going to give us the starting index of where that string can be found. If we do not find that string, it's going to give us -1. And if we start at 0, as you see on this picture, then we'll be able to count one by one until we find the string. So let's say that we are looking for, again, OR inside of George. And then we start at 0, which is G. And would this substring start here? It would not, because there's not a lowercase o. So it would move on to the next index. And it says, would this be the start for the substring OR? It would not, because it doesn't start with O. So then we move on. And we continue doing this until we find an O. And if we find an O and then we go, okay, I found an O. I know that my small string, the string that I'm looking for, has an R after the O. I'm going to look in this bigger string and see if there's an R after the O. And in this case, there is. So we have found OR inside of George, and then what index of is going to return is the start of where it was able to find that. So in this case, it's going to return 2, which is index of 2. And how can this help us? Well, if we're trying to find a message inside of a longer message or a word inside of a sentence, then we can say if the index that you found is greater than 0, so if you were able to find something in here, then go ahead and print some message. Otherwise, if you didn't find this word in this bigger sentence, then don't print, or print something else. We can look for two different strings within a sentence. So in this case, we're going to look for like inside of the bigger sentence. I don't like turtles. And if we find like, then what index of is going to return is some number that is going to be 0 or bigger. Because 0 would be the first letter, and technically we could find it right at the first letter. So in this case, in this piece of code, you would probably want to use greater than or equal to 0, but you can also use 0. So if we find the negative string NO, we're going to print negative. If we find the other string like, then we're going to print positive. In this case, we do find the string no, and that would be at index 1, 2, 3, 4, 5, 6. It starts right at 6. So index of will return 6, and it says is 6 greater than 0? It is. So then we would print out negative for this piece of code. Again, remember that when we're looking at whether something exists, like say a small string exists in a bigger string, like a letter exists in a word, or a word exists in a sentence, or a sentence exists in a paragraph, if we look for the index of the small string and we look for that in the bigger string and that returns something that's greater than 0, then that means that that we were able to find it in there, and that we can go ahead and do stuff because we were able to find it in there. If we look at substring, substring is another useful tool that lets us get a string that's smaller from inside a bigger string. So in this case, what we're saying here is that get me a substring of name 1, starting at the index 0 and ended at the index 4, but don't include the 4th or the 5th letter, which is the letter at index 4. So what does that look like? Well, we start at 0 and we go 1, 2, 3, and 4. Again, we don't include the letter at index 4 because that's our end, and instead we return the smaller index that we found from 0 all the way up to 4, but not including 4, which in this case would be capital GEOR. So if we were to store that in a variable, then we can use it because we found a smaller string from a bigger string. Two more that would be helpful. We are able to turn a word into all uppercase. So if we do GOR, which is the substring that we just found, and we do 2 uppercase, now it's all caps. And now we would have to store that in a variable. Make sure to store it in a variable when you use any of these string methods. And then lastly, 2 lowercase, it removes any capital letters and makes everything lowercase letters if possible. And using all of these string methods and comparisons, you can create some pretty good programs, which you will practice in when it comes to lab 6A and 6B.